Now, in the beginning of chapter 3, we have lots of terminology that we need to go through. Things that we definitely need to know and understand so that when we use these words later, you know what they are. Oftentimes we realize what the word is, but we don't think about it later. So this is another great opportunity for you to start writing a glossary of words and their definitions. The first thing that we're going to go through are multiples. When we learned our multiplication tables, we were learning multiples. We first learned how to count by 2. Well, when we were counting by 2s, we were learning the multiples of 2. When we were counting by 5s, we were learning the multiples of 5. So up here I have the example of a bunch of the multiples of 4. 4 times 1 is 4, so 4 is a multiple of 4. 4 times 2 is 8, so 8 is a multiple of 4. 4 times 3 is 12, so 12 is a multiple of 4. To get a multiple, you're taking a base number times another integer and getting a bigger number. So multiples are bigger than what we started with. So here are a list of the first 10 or so multiples of 10. Excuse me, the first 10 multiples of 4. Divisible. Now that's a hard one to find a definition of. Divisible. A number is divisible by another number if it divides it evenly, is some sort of definition that your book gives. Oh boy, that's really kind of complicated. So let's go through an example. If I had the number 24, what is 24 divisible by? Well, we have to think of all the numbers that go into or divide it evenly. 24 can be divided by 1. Every number can be divided by 1. So 24 is divisible by 1. 24 is divisible by 2. 24 is an even number, which means that 2 has to go in it. 24 is divisible by 3. 3 times 8. 24 is divisible by 4 and 6 and 8 and 12 and 24. So a number is divisible if it divides it evenly without a remainder. So all of these numbers divide 24 into even groups. So 24 is divisible by all of these numbers. That leads into our next type of definition of factors. Now, I said previously that terms is one of the main concepts that we need to understand in this class. The other thing that we need to start making sure that we understand are what factors are. Factors. Things that multiply together are our factors. So all of these numbers, 24 is divisible by all of these numbers. All of these numbers are factors of 24. Factors are the building blocks of that number. It makes it up by multiplication. 1 times 24, 2 times 12, 3 times 8, and 4 times 6 all give us 24. So these are all factors of 24. Now, we can also find the factorization of the number. Now this gets a little bit confusing. That's why it's good to have a glossary, because factorization looks a lot like factors. Factorization is putting those pairings together. This is just listing all of the factors. A factorization is putting them in groups and saying, oh, well, what does multiply together to give me 24? So the factorizations would be 1 and 24, 2 and 12, 3 and 8, 4 and 6. How about and 2 times 2 times 2 times 3. That's a factorization also. It's a special one. What is this one called? This is the key part of factorizations. This is called prime factorizations. This is the prime factorization of the number 24. Now this is the awesome thing about numbers. Every number has a unique prime factorization. Every number has a unique prime factorization. What do I mean by unique? In math land, when I say unique, it means there's no two alike. No other number has 2 times 2 times 2 times 3 as its prime factorization. It's a fingerprint for the number. It's like a snowflake. No two are alike. Now, what's it mean to be prime? That's another good word. Prime numbers. What are prime numbers? Prime numbers are numbers in which their factors are only one in itself. Oofta. So when I'm trying to say, what are the factors of the number? It's 1 times that number, and that's my only option. 2 is the only even prime number. The only way that I get 2 is 1 times 2. 3 is a prime number, because the only way to get 3 is 1 times 3. 4 is not a prime number, because 4 is 1 times 4, or it's 2 times 2. There's another set of factorizations. So 4 is not prime. 5 is prime. 6 is even, so that's once again not going to be prime because we'd have 1 times 6, but there's always 2 times some number when we have an even. So 6 is not. 7 is prime. 9 is not. Remember, that's 3 times 3 or 1 times 9. So it's both. 11 is prime. 13, 17, 19, etc. These are prime numbers. So when I break a number down into these numbers, I've done a prime factorization. That's also known as a factor tree. So to do our prime factorizations, is making a factor tree. Maybe you remember doing those. So if we once again look at that number 24, to do a factor tree is to say, okay, what times what is 24? And we say, well, I don't know what I remember. First one that always popped to my mind was 4 times 6. It doesn't matter which you choose as long as it multiplies to 24, because then once you break it down, it'll always get to the same end result. Now 4 is not prime, so we keep going. What is 4 made up of? So we make our 2 little branches and say, 4 is 2 times 2. Now 2 is one of our prime numbers. Remember, it's the only even prime number. So once I get to a 2, I'm done, so that's a leaf. Here's a leaf. This 6 is not prime, though, so I have to break that down. So 6 is 2 times 3. 2 I can't break down any further because it's one of my primes. 3 is one of my primes. And now I have leaves at the end of all my branches. So the prime factorization of 24, we'll make sure that we write them in numerical order, is 2 times 2 times 2 times 3. That is the prime factorization of 24. You find prime factorizations by making factor trees. Fractions. Fractions are made up of a top number called a numerator over a bottom number called a denominator. A fraction is a portion of a whole. It's a fraction. It's a part of something. So instead of having whole items like we've been talking about before, we're taking a pie essentially and cutting it into pieces. We don't have the whole pie, we only have part of it, or a fraction of it. One of the things that we do with fractions is we reduce a fraction. Now if I had the fraction 8/12, this is not reduced because there is a common factor that goes in the top and the bottom. Now how we learned how to simplify our fractions was saying, oh, what goes into 8 and 12? And we'd say, oh, 4 goes into both of those. And so then we'd say, oh, 4 goes into 8 2 times. And 4 goes into 12 3 times. So our answer would be 2/3. That is fine for you to reduce your fractions. But I want to show another way because I want you to understand why you can do that reducing. It's going to help us next week when we are doing our adding and subtracting, and we're doing this procedure essentially in reverse. We learn how to do things, we learn how to undo them in math land all the time. So let's go back to the 8/12. If we look at that 8/12 and we rewrite it as factors, remember factors are stuff that gets multiplied together, we may notice that 8 can be written as 2 times 4. Those are factors of 8. If we multiply it, we still get 8. So I didn't change the value of the 8, just what it was looking like. And I do the same thing with 12. I may look at that and say, oh, that's 2 times 6. Now, that's fine to do. Now, what we need to realize is, oh, look, I have a 2 on top and a 2 on the bottom. They share that factor of 2. Well, anything over itself, we know is equal to 1. Anything divided by itself is 1. If I have something I divide it, I can't have nothing. Okay, so 2 items divided into 2 groups, there's 1 item in each group. So 2 over 2 becomes 1. And so then we're left with 1 times 4 over 6. Well, 1 times anything we know is anything, and that's how we'd end up with 4/6. But wait a second, I thought my answer was 2/3. Ah, yeah, 1 times anything is anything. So now I have this 4/6, but what do we notice about the 4/6? We can break those into its factors as well. 4 is 2 times 2, and 6 is 2 times 3. And now we have the exact same idea here. I'm going to maybe write this in a different color. Oh, not that one. And once again, I have a 2 on top and a 2 on the bottom, which cancel out and give me 1. 1 times anything is the anything, so I'm left with 2/3. Wait a second, could that have seemed faster up here? What happened when I redid it this way? Well, we had our 8/12, but when we rewrote it, we didn't use all of our factors here. We just chose one of our groups. A way of getting around that is we either want to write out the prime factorizations. So that means the 8 we want to write as 2 times 2 times 2, and the 12 we'd want to write as 2 times 2 times 3. And then you can see all the pairs that match on top and bottom. Or what we need to do is think a little bit more and say, okay, well the 8 is 2 times 4. There's no really other way of writing that. I know 2 goes into 12, but 4 is a factor of 12 as well. So I'm going to use the factor that has the 4, and that's 4 times 3. Once again, anything on top that matches with anything on the bottom, if we are multiplying on top and on bottom, can cancel. 4 over 4 is that 1. So now I'm left with 2/3. And I was able to reduce that fraction in one step because we are finding the common factor and pulling it out. That's what we really do when we reduce. There are 2 methods that we can use to multiply fractions. if I have 3/4 times 8/9, remember that's what that raised dot in the middle means, is multiplication. If I have 3/4 times 8/9, I can multiply this two different ways. The first method is to multiply straight across, top to top and bottom to bottom, and then reduce your fraction. So in this case, I would take 3 times 8 over 4 times 9. So I would have 24 over 36. And then I reduce from there. Now the problem with doing that method first is that now we have these big numbers, and we're not very good at remembering what goes into 24 and 36, and it gets a little bit more complicated to do your reducing, but we could still do it in that fashion. However, I like the second method. If I had 3/4 times 8/9, I look for things that I can cancel. Now here are my rules for canceling. I can only cancel when multiplying. And I can only cancel a number that's on top with a number that's on the bottom. Only cancel when we are doing multiplication. So if we are adding or subtracting or dividing or solving, we cannot cancel a number on top with a number on the bottom. This only works when we are multiplying. But it doesn't matter if the numbers are right above each other or diagonally, as long as one of my numbers is on top and the other's on the bottom. So in this problem, what I notice is that I have a 4 on the bottom and an 8 on top. 4 and 8 share that factor of 4. So I say, how many 4s go into 4? My result is 1. How many 4s go into 8? My result is 2. So I reduce that. But looking at it before I jump ahead, I notice that, hey, I have a 3 and a 9 diagonally as well. Those share a common factor of 3. I can reduce that as well. 3 goes into 3 once, and 3 goes into 9 3 times. Now I did my reducing, now I can multiply straight across. On top, I have this 1 times 2, and on the bottom I have 1 times 3. I'm only writing this step out so that you can follow along. You'll probably skip that step and go straight to, well, 1 times 2 is 2, and 1 times 3 is 3. So our end result here is 2/3. There's only one formula in this class that you will be required to know, and that is the area of a triangle. Remember, when we're finding areas, we're finding out how many little squares would fill in this space. And since they're little squares, our label would be squares. You'll notice that this particular triangle has this little square in the corner. That lets me know that this angle is called a 90-degree angle or a right angle. That helps me identify the sides of the triangle to plug into my formula for the area. This bottom portion here is now called the base, and because this side here hits my base at this 90-degree angle, that is called the height. We don't care about this other point, or this other side at this stage. That is called a slant height, and we don't want the slant one. We want the two sides that hit each other at this 90-degree angle. Because the formula for the area says that area is equal to the base times height divided by 2. Now the reason that this formula is in this chapter on fractions is because another way of looking at that is saying that that dividing by 2 is the same thing as multiplying by the reciprocal. So we oftentimes look at this formula as 1/2 times the base times the height. Whenever you are looking for formulas, you don't have to go through the chapter. You can go to the back cover of your book where all of your formulas are located in one spot for you. So if you forget the formula, go to the back cover of your book. So for this problem, if I call the base down here 12 and the height over here 7, we'll call it inches, have to have our label on it, to find the area or how many little 1 inch by 1 inch squares would cover this space, the interior, we would say, okay, I'm finding area, so I leave A as A, is equal to B is the base, so that's 12, times the height. Now to indicate multiplication, I don't want to get too confused and think that I have a decimal point. So instead of using my raised dot, I'm going to put my height in parentheses to indicate multiplication. And then I divide the whole thing by 2. Once again, I'm allowed to reduce first if I see something that reduces. We only reduce one number on top with one number on the bottom. So the 2 doesn't go into the 7 and go into the 12. It goes into one or the other. Since 2 goes into 12, I go 2 goes into 2 once, 2 goes into 12 6 times, and I'm left with 6 times 7. So my area would equal 42. So there's 42 1-inch squares. Now I need to say what that label is. If I don't label it, it's not right because I don't know what 42 means. Because it was inches times inches, it would be inches squared. So we put the square on the inches because the label of inches is being squared, not my number. This is not 42 times 42. We already did the multiplication. There would be 42 1 inch by 1 inch squares that would cover that surface. So we call it inches squared. If you're not comfortable with using the little square, you could write it out 42 square inches. So you could just use SQ as your abbreviation for square. What if this number had been an 8 instead? We'd still have 12 times 8 divided by 2. Now when we reduce, remember as I said before, I'm only reducing one number on the bottom with one number on the top. It does not matter if I go 2 into the 8 or 2 into the 12, but it's one or the other, not both. I like to always put my number 2 into my larger number. I can divide 12 by 2 fairly easily. And the reason I do that is because if I reduce that and make it a 6, I know what 6 times 8 is. Now I have two numbers that are less than 10. So they're in my multiplication tables that I memorized. If I go 2 into the 8, I'd get a 4, and then I'd be left with 12 times 4. I'm not as good with multiplying by 12 as I am multiplying single-digit numbers. So I'm going to go 2 into 2 once and 2 into 12 6 times, leaving me with 6 times 8, which is 48. Once again, square inches. And that's how you find the area of a triangle. Before we can learn how to divide fractions, we need to understand the word reciprocal. Reciprocal, notice it has just about every vowel in the word, so it's really kind of a fun one. A reciprocal simply means flip the fraction. So if I had the fraction 2/3, its reciprocal is 3/2. If I had the fraction negative 7/4, its reciprocal is 4 over negative 7. Now the negative doesn't have to stick with the 7. You could keep the negative up on top if you wanted to, or you could put the negative out in front. There are 3 ways of writing a negative fraction. Negative out in front, so negative 1/2. You could have the opposite of 1 over 2, or 1 over the opposite of 2. All 3 of those are perfectly legal to represent a negative fraction. There are 2 ways of representing a positive fraction. 1/2 would be a positive fraction, and negative 1 over negative 2 is also a positive fraction. However, this one is not simplified, and you would lose a point if you left it that way, because a negative divided by a negative, you would always want to simplify to a positive. So thinking of this 1/2 that we have up here, if I had a 1/2, what's its reciprocal? Well, we still flip it over, so its reciprocal would be 2 over 1, which 2 over 1 is the same thing as 2. So what's the reciprocal of negative 22? All whole numbers or integers can be written as fractions. It's not just a negative 22, it's negative 22 over 1. And flipping that around would give us, so reciprocal would be the flipped fraction with 1 on top. We need the reciprocal in order to divide our fractions. The rules for dividing fractions is always stated, multiply by the reciprocal. Those are big words, and if we don't remember what they mean, we can't then divide. So the easy way is to remember, flip the second fraction and multiply. Now the key here is that it has to be the second fraction. We never flip the first fraction, it's always the second fraction. So please keep that in mind and remember that. I saw online a nice little rhyme that can help. Dividing fractions is as easy as pie. Flip the second and multiply. So if I have 7/10 divided by 1/2, we never do anything with the first fraction. That's going to stay the same. So it's going to be 7/10. But instead of dividing, we flip it so we multiply. Now once again, let's get away from using the cross for multiplication because we want to get ourselves prepared for algebra. So I'm going to use my multiplication dot instead, and then I flip my fraction. So I have a 2 on top and the 1 on the bottom. Now that I have multiplication, I use one of my 2 multiplication rules. Either I multiply straight across and then I reduce, or I reduce and then multiply straight across. In this case, I recognize that I have a common factor of 2 on top and bottom with the 2 and the 10. Remember, you can only reduce with 2 numbers. So 2 goes into 2 once, 2 goes into 10 5 times. Multiplying straight across, I then have 7 times 1, which is 7, and on the bottom I have 5 times 1, which is 5. Now, I want us to be well prepared for the algebra class, so I do not do anything with 7/5. I know the top number is larger than the bottom number. Oftentimes when we see that, we think that we have to rewrite that as 1 2/5. I don't want a mixed number. 7/5 is called an improper fraction. We like improper fractions. In algebra, you will only have proper and improper fractions. Reduced, of course. Always reduce your fraction, but do not convert it. Putting it from one form to another form is a conversion. Taking a common factor out is a reduction or reducing. You always reduce your fraction, but we don't convert them. So you keep it as an improper fraction because we don't do mixed numbers in algebra, and I want you to be prepared for that. The last thing that's introduced in this chapter is solving one-step equations now that we understand fractions a little bit. Now we're only multiplying and dividing fractions, so that's the only type of step that you will see in this week's problems, is that here we have 2/3 times x is equal to 8. Now we've said earlier that since this is multiplication, to cancel out multiplication and get our variable by itself, we would have to use division. However, if we look at that, dividing both sides by 2/3, we'd say, oh, divide this by 2/3. That's really ugly. That's called a complex fraction. We have a fraction on top and a fraction on the bottom of another fraction. We don't know what to do with that. We'd have to divide the other side by 2/3 as well. And that gets a little confusing and a little scary. So let's go back and use some of the knowledge that we have to do this problem a little bit neater and a little bit easier. Now we know we have to divide, but what did we just say? How do we divide fractions? We multiply by the reciprocal. So instead of dividing by this 2/3, I want to flip that and multiply. Now, what happens when we multiply this reciprocal by the 2/3? Multiplying, we multiply straight across, we'd have 3 times 2, which is 6, and on the bottom we'd have 2 times 3, which is 6. 6 over 6 is 1. So this would all cancel out, giving me a 1, and I have my x all by itself. Now don't shortchange it. I multiplied this side by 3/2. Remember, I have to do the same thing to the other side. So by multiplying by the reciprocal, this became 1, which is the same thing. 2/3 divided by itself, anything divided by itself should be 1. So we get the same result. Now on the other side though, we need to do a little bit of thinking here. Remember, this is not 8 over 8. Any number over itself is 1. This is 8 over 1. Any number over 1 is itself. So now I can see that I have 8 times 3 over 1 times 2. Once again, you can either multiply and then reduce, or reduce first and then multiply. Any of that focused? So I'm going to reduce this. 2 goes into 2 once, 2 goes into 8 4 times. Now I'm left with 4 times 3 on top, which is 12, and 1 times 1 on the bottom, which is 1. 12 over 1 is just the whole number, 12. So our solution here would be that x is equal to 12. Let's try another, especially in case that one did show up. How about 2/7 x is equal to -6? Once again, we would be dividing by 2/7, but instead of doing that, I'm going to multiply by the reciprocal because it means the same thing. So I'm going to multiply this. I have a 7 on the bottom, so I would need a 7 on top to cancel. I have a 2 on top, so I would need a 2 on the bottom to cancel. 2 goes into 2 once, 7's go into 7 once. I'm left with 1 times x, which is x. But don't forget, I multiplied this side. What did I multiply by? 7/2. I have to do that same thing to the other side. Multiply this by 7 over 2. Once again, this whole number, I'm going to put that over 1 to remind myself that it's a fraction. It's over 1, not over itself. Then I reduce that side. 2 goes into 2 once, and 2 goes into 6 3 times. I have -3 times 7 is a -21, and the bottom is just 1. I don't need that. Let's try another one. Here I have -9/8 is equal to 4x. Now don't get confused because the variable is on the right side instead of the left side. The goal is still the same. We're trying to get x alone. We need to get rid of the 4, not the 9/8. Now to get rid of the 4, I would divide by 4. But dividing by 4 is the same thing as multiplying by the reciprocal of 4. What's the reciprocal of 4? 1/4. So I'm going to multiply this by 1/4. I'm putting it right next to it so we can see how the 4 on top and the 4 on the bottom would cancel. If I do that on the right side, I have to do the same thing on the left side. So I'm going to take this fraction times 1/4. Now you'll notice here, the 4 and the 8 do not cancel because they are both on the bottom. Oftentimes when we see the original problem, we start automatically assuming that we get to cancel. Do the mathematics, don't assume. So in here there's nothing that can cancel, so I multiply. Remember this is 1 times a -9. A positive times a negative is going to make that a negative 9. And 4 times 8 is 32. 4's cancel over here. 1 times x is x. So my solution to that one is that x is equal to negative 9 over 32.